Hey folks, today we're going to talk about balancing equations. In other words, making the numbers work. Okay, we're going to talk about that a little bit. Think about when you go to a dance. If you were to go to a dance and 100 people went in the door, at the end there are going to be 100 people who go out. So they may not come out with the same people, you may not come out with the same people you went in with, but there are going to be 100 coming out if there were 100 going in. All right? So this is called the conservation of people. So if we think of this from the conservation of matter perspective in chemistry, whatever ingredients we put into making chocolate chip cookies, which is what you're looking at here, will come out in the chocolate chip cookies. So all of the flour is still there, all of the butter is still there, all of the chocolate chips are still there. They're just in a different form. They've gone through some chemical reactions. Okay? So the same thing is true when we start to talk about chemistry. So let's talk, for example, about creating methane gas from carbon and hydrogen. Now, methane gas, for those of you who don't remember, is CH4. So if I take carbon, and carbon is just carbon, and I take hydrogen, hydrogen is actually bonded to hydrogen. So I've got an atom of carbon, and I've got two atoms of hydrogen that are bonded together. And what I want to produce is I want to produce CH4. So there's carbon, and there's hydrogen, and there's another hydrogen. The problem is I've only got two hydrogens. I need two more. Where do I get them? Well, I get them from another molecule of hydrogen, which is H bonded to H. Remember, hydrogen is one of the Brinkelhoff elements, so it's always bonded to itself in its elemental form. So now I can use those other two hydrogens, I can break them apart and bond them to carbon, so I get my CH4. So what have I actually done? Well, I've taken one carbon, and I've taken two H2s. There's an H2 and there's an H2. So there's H2, but I've got two of them, and I've created one CH4. So I have exactly the same number of carbons and the same number of hydrogens on both sides. And notice I added this thing called a coefficient in front of the H2 to tell you that I had two H2s. Now, methane burns in oxygen to produce carbon dioxide and water. So that's another example. So let's go and look at methane, which is CH4. So let's actually draw it as CH4. And it burns in oxygen. Now remember, oxygen is also a Brinkelhoff element. So it's bonding with oxygen, bonded to oxygen. And we're producing carbon dioxide, which is oxygen bonded to carbon, bonded to oxygen, plus water. Oxygen bonded to hydrogen, hydrogen. So let's see what happens. We have carbon over here on the left, and we have carbon over here on the right. So that looks great. We've got one carbon on both sides. We've got four hydrogens on the left, and on the right, oops, we have a problem. We only have two hydrogens on the right. Well, that means I'm going to need another water, because I need those two more hydrogens. So I can always add stuff. I can never take stuff away. So I added another water, so now I have four hydrogens. So that's good. And now I have an oxygen here and an oxygen here to balance the oxygen there and the oxygen there. So I'm done. Oh no, wait a minute, I'm not done. I've got an oxygen over here and here. Where do they come from? Well, to have them, I'd have to have another oxygen over here to give me my four oxygens that appear on the right. So now what do I have? Well, I have one methane gas plus two O2s. Notice I didn't say O4s, and notice I didn't say four O's. I didn't say either one of those. They're not correct. What I have to say is I have to say O2 because it's a Brinkelhoff element, and I've got two of them. And over here I produce a CO2, and I produce two waters. I don't produce H4O2, that's not water. I produce two H2Os. Right. So, how do I balance these things without using models? Well, frankly, there are two ways to do this. And Mrs. Sherman and myself and Bergman and Sams, I believe I'll do these the same way. And Mrs. Can has a different way of balancing, and she creates some matrix to do it. And in all honesty, I can't do it that way, and I can't do it justice. So if you get stuck on this and this is really hard for you and you're really confused, come see me or come see Mrs. Sherman. If that doesn't help, then please go see Mrs. Can, because she can explain it a different way. Right? So let's go ahead and see how we do this. I treat the arrow like an equal sign. This thing I treat it as an equal sign because the same number of atoms of stuff have to be on the left as are on the right. So if I have one carbon on the left, I have to have one carbon on the right. 2 carbons on the left, 2 carbons on the right, etc. I have to have the same number of each atom on each side of the arrow. And to do that, I can only change the coefficients, and that's where these lines come in. Those are the coefficients. So I can change them, I can make them bigger, but I may never, ever, ever touch the subscripts. Once the subscripts are set, you may never change them again. Okay, so what I tend to do is I tend to work left to right. Now I will notice that there are certain tricks along the way, and I'm going to talk about those in the subsequent slides here. But I typically work left to right, and so to do that, I'm going to check the number of carbons. And I have 1 carbon on the left and 1 carbon on the right, so that's okay. I've got 4 hydrogens on the left, and I've only got 2 on the right, so I have to fix that by putting a 2 there. So I now have 4 hydrogens on the right. And I have 4 oxygens on the right, so I have to put a 2 in front of my oxygen to make it 4. And now I go back and check my work. And this last line is very, very important. I repeat until everything balances. So I keep doing this over and over and over again, back and forth, until I'm completely balanced. So when you balance, you must have the coefficients in the lowest whole number ratio. So if you ended up with 2 CH4s and 4 O2s and 2 CO2s and 4 H2Os, you'll notice they're all divisible by 2. You really should have 1 CH4 and 2 O2s and 1 CO2 and 2 waters. Now you'll notice I never wrote a 1 in front of the CH4. That's okay, because the 1s are implied. So if you don't have a 1, that's cool, don't need one. Now if you put 1 in, it's perfectly fine. Right? That's okay. It's just completely unnecessary. Alright, so pause the video if you would please and see if you can figure these 2 out. And then come back. Okay, I've got 1 calcium on both sides, but here I've got 2 oxygens on the right. I've only got on the left, I've got 1 on the right, so I have to put a 2 there. When I put a 2 here, I broke the calciums. So my calciums are no longer balanced, so I have to put a 2 on the left. You have to be careful about that. Now sometimes these all work out. I put 3 calciums on the left because I've got 3 on the right, and the 2 nitrogens on both sides are good, so I can leave that alone. Alright, what happens when you have polyatomic ions? This looks really, really confusing, but guys, notice that on the left-hand side, I'll do one for you. Notice on the left-hand side you have ClO3, and you have ClO3 on the right, and they're the same. So you can just treat those like you have a thing. And the same thing for SO4s. You've got an SO4 up here and an SO4 down there. You can just treat them so long as they don't change, so long as it doesn't become something like SO3 or SO2 or SO5 or some other silly thing. Then you can just treat them the same way as 2 things, just like they're X on both sides. Alright, so now I'm going to go through and I'm going to balance. And again, I start from my left, so I look for silver, and I notice I have 2 silvers on the right, so I have to put a 2 in front of that. The next thing is my ClO3. I now have 2 ClO3s. I don't have to break it down to 2 Cls and 6 Os. I can just say I have 2 ClO3s, and I have 2 ClO3s on the right, so those are balanced. I have 1 calcium on both sides, and I have 1 SO4 here and 1 SO4 on the other side. So those all balance, so I can leave them alone. So I should be done. Alright, you try the next one and see what you come up with. Alright, the FeCl2 is not a problem, but you do have a polyatomic ion over here, which is PO4. And I notice that I have 2 of them on the right. I'm not going to fix that yet, but I do notice I have 2 of them. Alright, so let's see what we come up with. I have 3 Fe's on the right and 3 Fe's now on the left. That means I have 6 chlorines, 3 times 2. So that means I have to have 6 NaCls. So I have 6 NAs, that means I have to have 2 Na3s to make 6. That gives me 2 PO4s, and I have 2 PO4s on the right, so I am done. Alright, what happens if you have 2s and 3s? Sometimes you'll notice where you have 2 on one side and a 3 on the other. For example, in this first one, I have KClO3, and notice it breaks down, it decomposes, and I've got O3 on the left and O2 on the right. whenever I see 3s and 2s, what I do is I need to find my least common multiple, which is 6. So my 3s and my 2s are going to cancel. So I'm going to end up with 3 O2s and 2 O3s. So notice my 2 and my 3, I have 2 O3s, which means I have 6 of them, and I have 3 O2s, which means I have 6 oxygens completely. So that's the easy way to do that, and then I balance everything that's left. Well, I have 2 KCl's, so I have 2 KCl's there, and I am done. How about my next one? See if you can do this one. Pause the video, you try it. Okay, well again I have a 2 and a 3 for my oxygen, so I put a 3 in front of there and a 2 in front of there, which gives me 4 aluminums. I have 4 aluminums and a total of 6 oxygens. And that's that one. Alright, sometimes it can get pretty confusing because I have O's or H's or both in multiple places. For example, over here on the right, you can see I've got NH3, and I've also got H2O. So H's are going to be real hard to balance, and the O's aren't any better because I've got O2s and a single O on the right. So that's going to be a problem. So what I like to do is I like to balance everything else first. So what can I balance? Well, I can balance the N's, and I notice I have 2 N's on the left. So that means I have to put a 2 in front of my NH3. Well, let's balance the carbons. I have 1 carbon on the right. I've got one on the right and 1 on the left. So my carbons seem to balance. Well, that just leaves everything else. So let's look at my hydrogens. Well, here I've got a total of 6 of them. 2 times 3 is 6, but I still have 2 over here, so I have a total of 8. And 2 times 4, gratefully, is 8. Well, how about my oxygens? Here I have 3, and here I've got 2, and here I've got 1, so that's a total of 3. So I'm balanced, gratefully, just simply by putting the 2 in front of the ammonia or the NH3. Right. Pause the video if you would, please try the next one. Well, my H's are not a big deal because they're only in one place, but my O's are in 2 places on the right, so I'm just going to leave my O's alone, and I'm going to try everything else. All right, well, my nitrogen, I've got 1 nitrogen, and my hydrogens, I've got 3 on the left and 2 on the right. Ooh, wait a minute, 3 and 2, I know what to do there. I put a 3 over here and a 2 over there. Cool. So, oh gosh, but when I put the 2 in front of the nitrogen, I messed up my nitrogen. So let me go back and fix that. So I have to put a 2 here. So now what do I have? I have a total of 2 nitrogens and 2 nitrogens, and I've got 6 hydrogens, and I've got 6 hydrogens, and I've got 2 oxygens on the left, and I've got 2, 3, 4, 5. Oh, yuck. Now what do I do? Right. Well, I'm actually jumping ahead to the next slide, but this is a good time for you to go and notice it. Is you said, well, what do I do here? Well, really what I have is like 2.5 or 5 halves here of O2s, and you can't do that. But you'll notice 5 halves puts a 2 in the denominator. What happens if I double everything? If I go and I take this and I double it to 4, and I take this 2 and I double it to 4, and I take this 3 and I double it to 6. Well, now I've got 4 nitrogens on both sides. That's cool. And I've got 12 hydrogens on both sides. That's cool. Well, how about my oxygens? Well, I've got 4 oxygens here, and I got 6 oxygens there. It's a total of 10 oxygens, and O2s, that means I would have 5. Well, if you remember, I had 5 halves, and now I've got 5, because I multiplied everything by 2. So that'll help you as you do the next one. So, guys, see if you can do these. Again, remember, when you come up with something as a fraction, where it's a half, just double everything and see what happens. All right, pause the video, see if you can do these. All right, I've got 2 carbons, I've got 6 hydrogens, everything works. Now I've got 4 oxygens here and 3 for a total of 7, and that's where I run into a problem because I've really got 7 halves here. So if I take everything and double it, I would have 2 of those, I'd have 4 carbon dioxides, I'd have 6 waters, and what you're left with here is 7 O2s. Really? Do I really have 14 oxygens on the right? Well, 2 times 4 is 8, plus 6 more is 14. So yes, I do. All right, go ahead and try the next one. Pause the video if you need to, and then come back to it. All right, I've got 6 carbons. I've got 7 H2Os to make 14 hydrogens on both sides. And now when I count my oxygens, I've got 12 here, and I've got 7 there, for a total of 19. So that's 19 over 2. 19 over 2. So what I need to do is multiply everything by 2. So I'm going to multiply this by 2. I'm going to multiply this by 2. I'm going to multiply this by 2. And when I multiply the 19 over 2 times 2, I get 19. So I have 12 carbons on both sides. I have 28 hydrogens on both sides. And I've got 38 oxygens on both sides. They're 24 over here, plus 14, make a total of 38. All right, one last one that can get you is that sometimes water breaks up into H and OH instead of H2 and O2. Sometimes it breaks up into H and OH. So for example, look at the first one, and you'll notice I have an acid with HCl, and I have a base with OH, and my H's and my OH's are going to combine, all right, to make water, which is HOH. So let's go ahead and try this one. I'm going to ignore that for a moment and jump to the next thing, which is chlorine. I've got 1 chlorine. I've got 2 chlorines over here, which means I need the 2 in front of this. I've got 1 calcium and 1 calcium. So now here I have 2 hydrogens. So I've got an H and an H. And over here I've got 2 OHs. I've got an OH and an OH. And HOH is water, or H2O. And I've got 2 of them. So I got a 2 right there. All right, see if you can do the next one. Pause the video and try it. All right, well, I noticed that I have H over here, specifically H2, and I have 2 OHs. I've got SO4 on the left and SO4 on the right, so that's good. I've got calcium on the left, I've got calcium on the right. So this leaves me on the left with 2 H's and 2 OHs. So that gives me 2 waters. So all I have to do is put a 2 in front of that, and I'm good to go. All right, that is it. Remember, sometimes you're going to be getting things in word equations, and you have to convert them to formulas. So just be conscious of that, because that's something you're going to have to do. If you have questions, folks, please ask us in class. We'll be happy to help. And please do your worksheets. You've got lots of problems there, and we'll see you in class. Have a great day.